Right, now we'll roll swiftly into the first panel. We've actually, Hugh, he probably looked at the programme, but he's been a fantastic scene setter because we're talking about, first of all, talking about the state of the art in terms of the technology. We then have a panel on security. Then in the afternoon, we have a panel on the business and economic issues. And finally, we have a panel on the human issues, social science, the privacy, and the ethics. So all those things you ask questions about, we can tease out a bit more. See, Hugh's got to go because he's got to run the MOD now. We have the panel sessions. There will be more time for discussion. So we're going to start with the panel on the technology. I forget what it's exactly called, but it's something, yeah, technology, good. And I seem to be the chair, so that's good. I'll stay here. It's very easy. I don't have to do anything except introduce the speakers. I'll try and keep them to time. They've each got 7 minutes. And they'll come up from the floor up here to speak, because if they come up here, sit up here the whole time, they can't see each other's slides. So it's my pleasure to introduce our first speaker today in the panel this morning, Professor Julie McCann from Imperial College here in London, who is a Professor of Computer Systems, and you can read her bio. She leads the Adaptive Embedded Systems Engineering Research Group as Director for the, oh, that's a long title, for Imperial Centre for Smart Connected Futures. She probably knows more in her little finger than I know about the Internet of Things and everything. So, Julie, your time to speak to us. Thank you very much.
Thank you. Thank you for inviting me today. Okay, so you'll probably hear different versions of different definitions of what the Internet of Things is. You'll probably also hear people like me use other terms that we kind of more or less equate to the same thing. So anyway, normally when I talk to everyday people what the Internet of Things is, they tend to think of smart homes. My focus, however, is not really on the whole smart home thing, but I do know people here today will be talking about that aspect of the Internet of Things. I'm more interested in what I tend to describe as the belt and braces end of it, the ugly underground, grey box end of the whole subject, where we're basically building systems to help with utility, the running of utilities, to help optimize systems that work in the world. And we tend to want them out of the way. We don't want them to be the most visible of systems. So we're talking about, large utility monitoring and optimization and so on. And so where I've particularly been focused, to give you a bit of idea of the context of where I see the opportunities and challenges, I tend to look at things, for example, I'm also looking at precision farming. I'm interested in it from the perspective of understanding how soil impacts the growth of vegetation rather than necessarily looking after animals. And I love the challenges of that because I have to shove these systems in under the ground and it's really difficult for them to work there. I'm also interested in the more generic aspects where it overlaps with the world of robotics in the Industrial 4.0. And I'm interested in smart cities generally, where the smart city has a number of facilities and utilities to run the city to help to optimize the use of the city for the citizens of the city. And I want to maximize that given the lack of, we're in bounded resources and so on. So this is the kind of background I come from. Now, there's other opportunities we're starting to see come forward. One of them is the far side there. I'm not going to run the video, but we're starting to see these systems actually now being printed in situ in places like cities or so on. And also we're starting to send these kinds of systems out to space. And my lab is looking at a lot of these problems and issues, but we're starting to see certain common challenges with regards to those kinds of systems. And this is what I will to articulate. The first one is in cities themselves, to get people to adopt these kinds of technology, they have certain prerequisite ideas. One of them is very much the idea of them being out of the way and low cost. And this has implications for the types of systems we choose. Therefore, we're talking about systems that can't run the wonderful security algorithms that we have in existence now. We have to look at new ways of doing this because some of these systems don't even do floating point arithmetic. We're talking about low-end computer systems and low-end, what we call slower communications systems. The other thing we have to look at is the scale of these systems, both across the actual expanse of what we're covering, for example, a countrywide water network, And we also have to understand that these systems are all operating in the same physical area. So we've got the tight density of these systems. And then trust and security are obvious things we have to look at. Now, because these systems typically are in the low-cost, low-powered end of computing, they have certain behaviours that are not as predictable as, say, your laptop or even your phone. And so we have to accept that these systems will fail and that we can't predict all the situations that they will live in. So what we've done as a community is typically build systems that borrow almost from the approach that nature takes, which is to make the best of the current situation it's in, and then from that ripple out decision making. So we're talking about more bio-inspired styles of computing. So that has worked very well, but there's a negative with that. It's very much less able to predict those behaviours, to make guarantees about convergence and so on and so forth, and now we're starting to explore that. Furthermore, the conversation about density is an important one, because if we're expecting billions and billions of devices to be on our bodies, in our environment and around us, all communicating at the same time, we have to be really conscious about how we're going to get those systems to do that in a fair way that doesn't saturate the air, essentially. So we're starting to look at new ways of doing that. There's a number of people looking at that, and one of the things, for example, that we're interested in is looking at an alternative mechanism of communicating which uses your mobile phones to send my sensor data and incentivizing you to do that. Also, we're about to race a traditional system, which is low-powered wide area network, LoRa, against one of these systems to see what happens. Another Achilles heel in these systems is the batteries, and the batteries are basically something that you can't keep replacing if they're out in an environment like underground or under bridges and so on. So we're starting to look at energy harvesting mechanisms to guarantee a lifetime of those. And it's not just a case of being able to obtain energy from the environment, you have to be able to budget that energy over 10s and 20s of years, and that's non-challenging, or it's very challenging, sorry, non-trivial. The other thing that we have to look at is that we're not the only people putting these systems out there. There are other people who are the making community and so on are putting these systems out there, and they're starting to challenge some of the results that the more official systems are reporting. And we're going to start to see how that also has impacts. But finally, I want to really talk about one thing that I think is the biggest impact, and it's why we don't just focus on data. Because these systems are delivering data to your analytics systems, and they're not necessarily telling you the full truth. And it's because we have these systems embedded in a physical environment, they affect the physical environment, and the physical environment is physically affecting them. And this cyber-physical interaction, at the moment, we cannot determine, model, reason about, and give guarantees about. Therefore, the data coming in cannot be trusted in the same way you would expect from a larger, more robust system like a phone or a supercomputer, etc.
Thank you, Julie. Now it's my chance to introduce the person who pretends to be my boss in this world, the Dean of Physical Sciences and Engineering. Yeah, that's what it's the faculty I used to run. Professor Bashir Al-Hashimi, who, apart from being a dean, which is a horrible job these days in a university, is an expert in the world of embedded systems from the electronics point of view. Has the Arm professorship at Southampton, and is an expert in his energy efficient computing, which I think is what he's going to talk to us about now. Bashir.
Thank you, Wendy. We've heard already that it's all about data. I'm an electronics engineer. I'm interested in making devices that you need to start the Internet of Things. So I'll share with you some of the research we've been doing over the last 10 years, which I see it as a contribution to the visions of Internet of Things. It has got the right title. It's batteries will not be included, because at the heart of Internet of Things devices are electronics. This is how data get gathered. This is how data get processed. This is how data get sent and received. So if you get your starting point energy efficient, then at least you know that you have already contributed to the whole agenda of environment-friendly electronics. I'm going to try to, Right, so in order for me to explain what I mean by batteries not included, if we were to look at what would make an Internet of Things device, and we've already heard from Hugh that devices doesn't matter, well, you need to start somewhere. And devices is your starting point. So what you have at the heart of it is a processor. This is the thing that processes data. You have your sensors. You gather the data. Actuators is where actions are taken, and you need to send and receive. And you also need to store data. And at the top of it is energy source. You need an energy source to power your electronics. So the number of how many interconnected devices seems to change from time to time. Are they billions? Are they trillions? Well, we don't know. But what we know, there's going to be a lot of them. So if we don't pay enough attention to the electronics, then what we will end up with is a lot of batteries. And this is really what we're trying to do, trying to eliminate some of these batteries, and in some cases, perhaps complement batteries with energy harvesting, which is what I want to talk about. So do we need batteries? Well, the majority of Internet of Things applications tend to be in applications where there will be opportunities for ambient energy. And ambient energy is things like vibrations, light, flow, heat, and force. You could convert that to electrical energy, which then will power your electronics. So it sounds easy. What I have got here, you'll see a very short video now, which shows that this is an engine of a boat, which takes people from Southampton to Isle of Wight. And what we wanted to do is to monitor the health of the engine by looking how much vibration it generates. And we used that vibrations in order to collect data, process data, and send information to those who care about the maintenance and safety of the boat. So all of that electronics, and it's quite complex deliberately, because that application required complex electronics, was all self-generated. So you could imagine that if you were to move to wearable and implantable, you can develop electronics, but it's not going to be of that complexity because the amount of energy you can convert from ambient to electrical is limited. And that is the challenge, is how do you maximize and how do you ensure that the efficiency is high from ambient to electrical? So all of that works, and it was part of a big project we have led. And what I've got on the left is the size and the shape of the signals you get out of this ambient energy. And you can see they're all different. And that represents real challenges for how you design electronics that will be able to deal with all these cases. Right, so a typical Internet of Things device will be something like this at the end. What you got is a power supply, and to go from the energy to the computations and the processing, there's a lot of things in between. And typically you need about milliwatts if you're in sleep mode, or, sorry, nanowatt if you're in sleep mode, and milliwatt if you're in active mode. So the key to Internet of Things energy harvesting is about size, weight, and cost. As I've shown you in the previous videos, there was a big electronics device, but it was working well because we had a big engine. If you move to Internet of Things, what you need to do then is to reduce the size of energy harvesters. And to do that, where I have circled these 3 building blocks, is it needs to be designed in technologies that is lightweight, or in some cases you could get rid of. What I will do is show you the next case. Right. As I've said earlier, at the heart of Internet of Things device is a processor. And a processor is built using digital technology. And we have companies such as ARM, which makes them really, really well almost in every mobile phone. So what we have done is we have designed electronics that has got compatibility with the processor, but help us to do all the conversion from ambient energy to electrical energy. So what's available now? A processor that operates from an energy harvester. Just as much as what we have is a processor that operates with a battery. And this is a big step in the right directions, because now we can design Internet of Things devices that will operate from ambient energy. And most of the electronics needed for the conversion is already incorporated inside the processor. It's not all about energy generations, even though that we have made a lot of progress in how we convert efficiently from ambient to electrical. It's about how we use energy. So we started now to understand how we use energy in the context of energy harvesting computations. And these are scientific terminology which we use at conferences, but I will try to describe it in a non-scientific term. Pole neutral computing means I have started, so I'll finish. In other words, the computing, if I decide to do some computations, I will make sure that I complete it. Otherwise, I will have incomplete computations, I have wasted energy, and there is some mathematics behind this, which we have developed and established now. And transient computing, again, if I were to use a non-scientific term, is use it or lose it. So if you have captured some ambient energy and you converted it, you need to make sure that you use it. And that then will allow you to move away from having a supercapacitor, which where you stored energy. This is a simple demo. What you will see here is wind energy being generated. All that electronics goes from a sensor, transmitter, receiver, a lot of programming going on, and to aid the visual demonstrations, what you will see is lights being switched on and off. The energy you could use from such a wind energy, it will actually allow you to power almost every single Internet of Things device you could think of in an application. So the technology does exist from an electronics point of view, and energy harvesting, Internet of Things, should be something that comes to our attention when we think about designing the Internet of Things devices. With that, I will stop. Thank you.
Thank you, Bashir. You were perfectly on time. Thank you. You'll hear more from our first two speakers, all the speakers on the panel, of course. It's now my pleasure to introduce Derek McAuley, Professor Mac McAuley, who I first met, I think, well, actually it might have been before that, but 20 years ago, Dave DeRoy and I were involved in a project called Equator, which was an interdisciplinary research centre at Nottingham, with Nottingham, Southampton, Nottingham and others, which was all about the future pervasive computing. I think during that time was when the Internet of Things actually emerged as a term, but Dave or Matt might be able to correct me. Matt was definitely involved in that project as an industry advisor, I can't remember. But he then liked the ideas so much, he moved from industry to work at Nottingham, where he now is a professor of digital economy and director of the world-famous Horizon Digital Economy Research Institute at Nottingham. Mac, your take on the subject. Thank you.
I thought you were going to embarrass us by pointing out that we once did some work together for BCS, and that's 30 years ago. So I'm just going to pick up a few points. The first thing I want to start with is that in discussing the Internet of Things, we have to contextualize the discussions we have, because it's very difficult to make a statement that is universally true for all things. And the Internet of Things, the things is an unbound variable. It could mean anything. So we have to start contextualizing it a bit. Now, Horizon in particular, my research institute, we've been looking at the opportunities and challenges in personal data. And of course, this overlaps with IoT quite substantially. And since I was invited by Jeremy, I think the email came from him, I thought I'd use a digital catapult slide to make a point. So this is a survey taken a few years ago, and it's just the second statistic I want to look at. 65% of consumers are unsure if data is being shared without their consent. Now, in fact, under data protection law, there are many different reasons you can take someone's data, not only consent, but it's particularly an American view of the world that it has to involve consent, because legitimate interest is perfectly reasonable, and that's what the cell phone companies do when they track you all the time. So, but actually, this is a worrying statistic, because this is what people think. They're worried that they should have consented, and 65% of them think that the data may be used illegally, essentially. And that's not a good place to be. And this statistic gets worse every year. People's trust is getting undermined. So I want to look at this one very particular example. Here's a picture pulled off the interwebs, and I'm actually, it's a thing, it's a garage door opener, but actually I'm only really interested in the internet of, right? So we're going to look at just this one component and ask the question, what on earth is going on here? What is this cloud resources? In this application, which is to allow my cell phone to open the garage door, something that we all suffer from every day, there's a cloud resource in here. Why is it there? Because in 1981, we were told that one of the guiding principles of the internet was the end-to-end argument. That system did not need to be there in design terms, but we have managed to build an internet that breaks the end-to-end argument. We put in NAT devices in our homes. That's how we wire up our homes. We build a mobile infrastructure, and lots of your corporate networks will use private IP addresses. We built a system in which My phone cannot talk to my house. Okay? It can talk to something. I can go to lengths to cause this to happen, and I, as a professor of computer science, can manage this. But for most people, we end up having to go, everything has to go via a service provider. And in fact, the phone and the home connect to the service provider, and there they communicate. Now, the problem with this is that this service provider, someone observes the opportunity here, and they think, I now have all this data. The leprechauns will have placed a pot of gold with this data. And the number of businesses I've seen that said, we're going to monetize this data. It's like, you cannot monetize when people open their garage door. I mean, unless you sell it to criminals to tell them when they're at home. So the idea that the root of this, that we will monetize, and so we get to the position where companies are going, we have to gather more and more data because we can monetize it. It's very interesting that several years ago, both Microsoft and Google abandoned their services which had allowed you to upload your energy data, because they both decided that actually there was no money in looking at people's energy data at the granularity at which it was available. What's more suspicious is they both did it on the same day. But there's this myth that there's a pot of gold there. So my first issue is, let's make these things end-to-end. So number one, how many people are building Internet of Things that are IPv6 enabled? Very few. How many people even know that they've got IPv6 running in their homes? I have. BT will supply it to you. They won't give you a DNS so you can use it. You have to go and use Google's, but it is there. And actually getting to the point where the phone can talk to the home and get rid of the service provider for many domestic applications, and we talk about this in the connected home, is actually a good idea. Now, there are times where we do want to gather some statistical data, and I, as a user, want it. In this case, I use a Loop energy monitor in my home, and this allows me, because I've given them a small amount of demographic information, but bogus contact details, Mr. Lawrence Oop, who lives at the British Library, because they want to advertise to me from the energy data. They don't need to know who I am or where I live or anything else to advertise to me. They just need to know that I live in a 5-bedroom house and there are occasionally 4 people in it. So sometimes I want to compare myself with the population. So that's a valuable use of gathering statistics. But traditionally, this is how we've gone about analysing data. We take small and personal data, we aggregate it, and then we call that a big data problem. And then we analyse the hell out of it, and we get some statistics, and we make some decisions, we provide some service. That is the way of big data, okay? Now, actually, for many applications, you can do all the analysis at the edge. You certainly can for a lot of the examples where people talk about using electricity monitoring. You can do all of that. And actually, if there is a distributed computation you want to run across all the data, then mathematically what you're looking for is the sufficient statistics derived from the individual set of data in order to support that wide-scale calculation. And this is the sort of thing, and it's something that Hugh was mentioning, this issue of how much can you analyze the data at the edge before you share it is one of the ways in which we might go about doing privacy-preserving services, where instead of trying to steal all the data, you take, in fact, mathematically, you would want the minimal sufficient statistic, that is, compress the data down to the minimum form that supports the wide-scale computation. So let's just finish up then with something else, which is, here we're back to our example again. And I'm going to take a slightly different tangent now, and this is one of the questions earlier about where are the humans in this and what are going to be some of the drivers of security. So here's a paper from 1996. Automatic garage door openers, hazards for children. This documents 400 deaths in the US over 20 years due to garage door openers, causing hang-up injuries, choking, strangulation, and crush injuries. Pretty grim stuff. Okay, 1997, they pass a law in the US saying that a remote control for a garage door opener shall require constant pressure on a control intended to be installed and activated within line of sight of the door. This idea that you will use the cell phone and its GPS coordinates to notify that you're coming up the street and it should open the door is already illegal in the US. I attended a workshop recently where the question was, should the Internet of Things be regulated? And the answer is, for all things, there exists regulation. Name me a thing, a physical thing that is built that does not have some regulation associated with it. The tech industry doesn't get a buy on regulation. Oh, hang on, what about companies that Say, we're a technology company, we're not a media company. We're a technology company, we're not a taxi company. You can do some of these things when it's privacy and a few other elements of it. Start killing children, which is what an actuating Internet of Things will do, and we're in serious consequences. The key thing is that in a lot of the systems where people are talking about automation and AI, actually, a lot of this AI is pretty crap. I mean, this search can't even tell the difference between a router and a router. Our American colleagues don't quite get that joke. So, but the important thing is, and with that garage door opener, the critical thing was that there was a human in the loop. And a lot of these systems are presuming that we shall get rid of that, and that's very dangerous. So there are my takeaway messages, and we'll have the conversation at the panel.
Right, so now our last panellist this morning, Professor Sadie Creese from Oxford. She's a professor there of cybersecurity. She's well known as the leader of the Cybersecurity Centre at Oxford, and her bio talks for herself. She's done the thing we all do stupidly, flown in from Hong Kong. It doesn't look like you've just flown in from Hong Kong, Sadie, but anyway, your 7 minutes is now.
Thank you. So being a professor of cybersecurity, that will give you a hint as to what my focus will be. What I wanted to start by reflecting on is that the Internet of Things is, in a sense, a very natural evolution, an arrival of where we've come to. And I suspect that as we move through today, that's going to be dramatically obvious. So every single one of us is going to stand up here and talk about the heritage and the history that came before the current existence of IoT, and give you some glimpse of how we see the future playing out. And I too are going to say a few words about that. But what's exceptionally important, I think, and why IoT, and why this conference today, is not just the amazing business opportunities that we heard reflected on in the keynote this morning, nor is it the opportunity to change the face of the planet for humanity, which won't have passed us by. Of course, if you sit in rooms where you're debating how we're going to feed all the humans on the planet in the coming years, well, that will involve precision farming, space assets, monitoring, so that we can make adjustments to fertilizers in parts of the planet which we currently cannot grow anything, are entirely uninhabitable. Tech is inside everything. And as we've observed recently, and Wendy's opener reminded us of that, it's even inside our democracies and our social systems. And in fact, IoT is nonetheless, it's the ultimate fusion of humanity and technology. Of course it is. It's the point at which we instrument everything ourselves. Some of us have it inside ourselves now. Most of us will in 20 years, throughout the entirety of our environment. Never before have we had the ability to monitor and understand what's going on to this level. But we need to understand that these are not separate systems. It's easy when we hear all of us passionate scientists come up and talk about our favourite system that we're working on to imagine that these are all things that live in isolation. No, what IoT does for us is it finally brings it all together in this incredibly rich state. It is impossible for us to think of humans being outside this system. We've always been in the system, but we really, really are now, and we're an important component of it. And you cannot begin to understand IoT if you imagine you can separate out the humans. And I mean humans from a single individual, and the cognitive science and the psychology that helps us understand that, but I also mean human societies too, and the social effects of how we interact with technology. And so when I think about IoT and I think about cybersecurity, what the current state of the art is and where the opportunities and threats are moving forward, I naturally think of the convolution of science, but also creativity and everything that makes us humanity. So what's special about IoT? Why is it challenging, and what is the state of the art? Well, from my perspective, I think of it as the dynamics. So it's no particular component. They're all moving on. We've been working on these things for years. But it is, if you like, the scale, both tiny and huge. And so you get a feel for this, don't you? We have lots of small components, but we have very huge systems, in fact, many, many systems at all sorts of scales, all talking to each other. We have very, very large data sets, and we have minuscule pieces. And all of this stuff has to come together. And then all of these things have state. And there's some kind of glue. And if we, for 1 minute, imagine it's just standards that are going to give rise to that glue, we're wrong. It's our relationships. And some of those are going to be really long-lived. And some of them are going to be minuscule, highly temporal. If you imagine moving through this universe of stuff, just walking down a street, all of the different devices that are communicating and collaborating, and the human beings, and the human systems, and the relationships that are forming between these humans and the tech that supports them, and then the technology and the cars and the etc. That glue in itself has a dynamic, and we're going to be relying on it. And there's such a broad variety of components, and I don't just mean technology, but technology too. And at the edge of this, in terms of state of the art, is not just how you build the stuff. It's not just how you bring it together. It's almost how you conduct the orchestra and how you make the music. And the greatest value, of course, the people that will derive the greatest value, organizations, individuals, nations, will be the ones that know how to conduct the orchestra and bring these pieces together for maximum value. And in that, we see the movement of social machines, quite old now, but still incredibly relevant and perhaps well ahead of its game when we first saw it emerge into the scene, and also consumption. Not just how we optimize for human consumption or social consumption of data, information, intelligence, whatever you may call it, but also this moment of reflection where we might ask ourselves, should we be adapting what we ask for and what we wish to consume in order to deliver a very safe and secure Internet of Things? And all of these dynamics, these set the challenge space as well as the opportunity space, and not just for IoT in general, but for cybersecurity. And so my last slide, my last couple of minutes, I wanted to reflect a little on some of the cybersecurity challenges. And you know what? I'm going to put some dates around it, just to give us a feeling for the journey that, and this is a personal journey, and it's not all on there. So back in 2001 was when I first started working on what I would consider to be the Internet of Things. It was called pervasive computing, ubiquitous computing in those days, and I was working on what we referred to as spontaneous security protocols. What's that all about? That's actually about the observation that if you think for a moment you can possibly imagine on access to some backbone that's going to be some address book for the entirety of the world of devices, that you could say, what's the name of that person? Can I set up a secure communications, give me the key to encrypt my comms? Then we're going to be very wrong. And in fact, what we did there is we made some observations. We said, well, maybe we don't need to just do this in the technical domain. Maybe we can do some what we refer to as out-of-band comms, which means let's bootstrap it on some humanity, some human relationships, see if we can use those to seed some of the encryption that can immediately give birth to some encryption keys when the backbone is not accessible and it won't tell me what they're really called and what I'm passing through. So that was way back when. That stuff's actually being exploited and being brought to the market now. And then we moved on to, okay, well, in this world of devices, one of the classic attacks that we would worry about is somebody denying your service. And that might well be, I'm going to knock on your door and make you answer the door so much that you can't answer the door to anybody else. And then we moved to distributed denial of service. And we've recently, haven't we, in the press, seen in the last 12 months, some Internet of Things enabled devices around the world, actually cameras for security of homes, but it could be expanded to any device, including toys, being used to all at once conduct a DDoS attack on a single organization. Well, we were worrying about that, 2003 we began worrying about that, and we were thinking about topics like, for example, power scavenging. What will you do if somebody runs your battery down in an Internet of Things? Because that's a classic attack. I'm going to talk to you and keep you talking to the point where you have no energy whatsoever to do the normal job. How are we going to scavenge power from the environment? That's how we get resilience, right? How are we going to route when somebody's breaking my knowledge of where to send stuff around this Internet of Things? How am I actually going to start throttling the powers of an attacker so that their attacks are less potent? And then moving on from there, 2007, and all of this continues, of course. 2007, 2008, we get down to the third bullet. We started worrying about privacy because, and like previous speakers, I do not see the separation. Privacy is something that needs security. If we want privacy, then we will need security to provide our privacy. The two come together. It's just another property that we need to deliver in the system. Well, we started worrying about dynamic consent logics. Surely people are going to want to say, I'm going to share with this person, this organisation, and then I want to be able to change my mind. And then moving on, and I'm being told I have to come down off the stage, I'm going to finally pick on one more topic from that slide, which is incredibly important, and it's that of insider threat, which comes together with anomaly detection for myself. For those of you that aren't inside the security circles, you will not be aware, but it will become as a very obvious intuition, that over the years, the way in which we have delivered computer security, information security, and now cybersecurity has been born out of the natural intuition to build barriers and walls. That's what we have done as human beings. It makes utter sense. Let's build a structure around ourselves and keep the bad stuff out. But it won't have passed you by that every now and then you have something bad on the inside. And so we refer to that as an insider. What the Internet of Things will do, of course, for us, is rewrite our notion of boundary. Where is it in an IoT? Can you really separate one system from another? And what does a bad thing look like? Because I can guarantee there will be an awful, at huge scale, variety of bad things, and for that you will need to know normal in order to begin to understand what abnormal and possibly bad might be. And with that, I have to step down. Thank you.
Yeah. Do you guys want to sit wherever you like? It doesn't matter which order we're in now. Right, mics to the ready. That was a great set of talks to kick us off. Who would like to pose the first question, make the first comment? I'll probably take 2 or 3. Have you got anything to write on? No. Can you memorise? I'll take 2 or 3 questions and then let the panel decide what they want to answer. I think it gets more discussion going. Who would like to kick off in terms of... there was a gentleman's hand there. And then... yes. Sorry, just looking at Camilla there. I've got to remind you, Jeremy put his hand up as well, Camilla. Can you tweet people, if there's tweeters amongst you? And the hashtag is RSIOT. Nice simple one this morning. Please tweet away. Okay, please say who you are and where you're from. Yeah.
Dr. Leonard Anderson, Camiri. It's about the power usage and energy. Is there much to learn from space science? Because it takes a few amps of power to send a GSM message. What are they using in satellites? And is there anything to learn from space science?
Okay, can you hold that thought? Jeremy, you were next. Camilla, he's in the front row here. There's one here.
Thanks. Jeremy Watson, UCL and Petras. I was interested on the business model side. So if we're going to route around, if you like, the data analytics people, is the business model going to change? Is the investment in IoT as a platform going to be affected by that?
And then you had your hand up again, so would you like, yeah, we'll take this as a cluster and then get the panel to comment on.
Derek Gregory, retired from the Medical Research Council. Again, something very easy. And that is, supposing people become without their mobile phones, their computers, etc. They've got to use their intuition, their tuition, and their sense of direction, etc. And I get the feeling that people are losing this at the expense of the promotion of the sophisticated machines that you're talking about. Finished.
Okay, so there was learning from space science, which I'm going to throw to Bashir. We had business models from Jeremy. What are the business models for this? And then again, there were the human aspects in this, which I'll pass this down the road. So do you want to just pick up on anything about learning from space science?
The simple answer, absolutely. If the vision is to make Internet of Things self-powered, any knowledge we could gain from other disciplines should become part of our thinking. I don't believe at the moment enough attention has been given to the design of the devices themselves. And I think that is a mistake. Otherwise, we will end up with the same problem we have with batteries, with a lot of them, with our mobile phones. So the simple answer, absolutely.
I'm going to pick you up on that and just say, yes, I agree with you. But what about putting the human into this design loop, even at the level you work at?
I mean, these devices need to be interacting with the humans. I'm not an expert in human interactions, but my interest is very much making devices as efficient as possible, so we don't solve one problem and we create another problem around disposable of batteries. That is what I'm interested in, and any knowledge I could gain from other disciplines, that will be welcomed.
Can I follow on that?
You can.
I've direct examples of where that's been happening. I mean, space has been using solar panels for a long time. And one of the things they look at is how you optimize the tasks on board the spacecraft to be able to maximize the lifetime of that system. Some of those optimizations we're borrowing in these kinds of systems today. Furthermore, we're teaching the space community how we optimize our tasks at a fine-grained task level. That is the little bits of code that are on the computer and how they run. And so we're also informing the space community and the more futuristic space community that are using alternatives to the notion of batteries, the more nuclear-based power sources. They're also informing how we design our systems. But I agree, I mean, you have to have the human in the loop there. You don't want all sorts of nuclear leakage in your pocket. So, of course, we all think about those.
Mark, anything you want to pick up on?
No. Do you want me to do business models?
Whatever you want. Business models and the human in the loop.
Well, I think this is answer Jeremy's question about the business model. I think this is why it's very important to ask what context you're looking at. I was trying to figure out why I knew who you was, and I realised I did a job of consultancy for Rio Tinto a few years ago and wrote them a strategy for IoT. And I do remember reading his papers at the time. And it was very clear there what the business driver was and what the analytics were. They actually ran into issues with human beings, even though you think mining, surely there'll be no personal information there. When they were training the autonomous drill rigs, they realized that the population of human operators fell into two categories, those who were good at it and those who were really bad. And they realized they needed to train the autonomous systems on the really good ones, a lesson that we should think about in any of these training systems where we use data sets. And why we're ending up with bias and racial bias in algorithms, because we feed them biased information. But that's an example where, and we wrote a paper on that about how IoT would roll out in the mining industry in Resources Policy, weird journal. But specifically, I was looking at the home, and I think that there's much overhyped about how we're going to use this. And there's only so much advertising revenue on the planet, and more tailored advertising based on when I switch my lights on and off. It's just like. And in fact, a lot of people building the systems are giving themselves a data protection issue, which they do not need. They're actually giving themselves a regulatory burden, which costs money. So I asked the question, could you make more money by not having the data in the first place? But I think you need to look specifically at each sector and do that, as opposed to, you can't apply the architecture I was describing everywhere. But likewise, it's not all about monetizing data everywhere at the same time. And that's why I say it's very difficult to make these generic statements for all things. In the Internet of Things, this will be true, because there are no such statements, in my opinion.
Sadie.
Yes. Just reflecting on, it's a very interesting question, isn't it? But IoT has been evolving for some time. And my guess, a bit like cloud technology, another what will conceived to be very disruptive technologies to existing business models, is that it will be a pace slower, and it will encourage some defence, some protectionism, so a leaning, as Hugh was reflecting on this morning, towards vertical stacks, proprietary tie-ins, We saw it actually in security technologies 10 to 15 years ago from service providers. But nonetheless, the IoT will still continue to evolve. So it will hamper pace slightly, and it will hamper value slightly. I think one of the worrying perspectives, and something that we will have to keep an eye on, is whether the protection mechanism and response from some of the biggest players from the existing models will cause them to lobby so hard to protect the existing models that not enough is done to prepare for threats, etc. Because there'll be a lobby for don't regulate, don't do any more, don't try and attempt to expose us anymore to change. But what will then happen is they're so wealthy they'll move with it. So they'll play both ends, so that by the time they have no choice but for it to come, they'll be ready and waiting. Just as we've seen with all the other technology movements in the last 10 to 20 years.
Did you want to say something else, Jürgen?
I was going to pick up on the final question.
Yes, please do.
So there was a TV program a few years ago called Survivors, and someone, I think the producer or the director had recently said, you do realise that that scenario in which 90% of the population die of some terrible disease and everyone sort of figures out how to survive, it couldn't work anymore because Land Rovers you used to be able to fix yourself. Vehicles you cannot fix anymore. We have as a society become critically dependent on technology, and simple skills like the ability to navigate by looking at mountains and using a compass have been lost. And indeed, sailors these days are using GPS and praying it keeps working because they don't actually know how to take fixes anymore. I'm not sure what on earth we can do about that, but we as a society have become critically dependent on this, and it's not clear that IoT is going to, in any way, it's not going to make it better, and maybe making it worse, but I see it as pervasive that we have seen this. Most people in society today could not survive if you gave them 10 acres of land and said, and sufficient material to actually set themselves up for a year. They still couldn't farm. So, society's moved a long way in terms of resilience. We absolutely critically rely on everyone else in society and all of the technology that they support.
They're sparking off of each other. Bashir wants to say something else.
I just want to go back to the issue of energy. I mean, we often talk about big data. If energy matters, if energy costs matter, maybe what we also want to be thinking is quality of data. And we often think about intelligent software to analyze a large set of data. Maybe what we need is intelligent software that help us to generate quality data to start with. That has got additional benefits of being very efficient in your energy consumption. I'm not a computer scientist, clearly. My interest is making devices, and any knowledge we can bring together in order to get the right data and make the right decisions that has got benefits, clearly is the way forward.
I'm going to take the privilege of chair and say something about business models, because as a scientist, I always like to make this point somewhere in the discussion. It was Sadie that made me think of it. The Internet of Things is a bit of a misnomer because it's not an internet. It is things talking to an internet. And the characteristics of the Internet of Things business model are going to be very different to the characteristics of the internet and the web, which were both based on open standards and building on the network effect. So with both the internet and the web, the more people that use them, more computers attached, and the more people use the web, the more people, the more computers. The Internet of Things is a very different and actually makes a more complex model because of all the things we've been hearing about, the privacy, the security, the energy harvesting, all these things. And you've got very different business models because the market is seeking to make money. It's got to build widgets. It's got to sell those widgets into products that we buy, but there are no standards. There's no regulation. So it adds another complex dimension to the whole. This was the three-dimensional thing I talked about, and then you add AI on top of that, you've got four. So it is getting more and more complex, and how this will all roll out. This is why meetings like this are so important, so we can air these issues. Okay, let's get some input from I saw a hand go up there, gentleman with the blue shirt on, lady at the front here. I'll take those two first. Camilla? Lady at the front here, so we'll go up, and then we'll go back a bit. We'll take some more. We've got time. The gentleman in the blue shirt was first, and then...
Good morning. Ian Wills from Greyfield Consultancy Services. From the perspective of security and the Internet of Cheap Things, where, as you said, standards and regulation won't provide security, what can be done from a whole system perspective, perhaps in terms of emergent behaviours, to provide protection from rogue devices or even from rogue algorithms?
Can you hold these? It's harder because we haven't got things to write on. I really want to sort of go around and collect some questions. Hold that thought. I will just say I didn't say standards, and we shouldn't have standards and regulation. We haven't got them, and people have mentioned, Hugh did as well, that we need them, and we maybe need them at a meta layer as much as we need them at a particular device layer. Hold that thought. The lady here has the microphone now. Would you say who you are?
Susan Gray from the London Borough of Harrow. First of all, thank you very much for inviting me. It's really so interesting. But I have a question. As you've mentioned standards, supposing you have a memory card in a computer and you've used the memory card, say, in one borough of London, you then go, and it's worked fine. You then go to another borough in London or in the country, and it doesn't work. So it means that somewhere along the line, some data which we don't know about has got lost or has changed. So I'd like to ask you, please, perhaps that could be a standard, and thanks for listening.
That's actually an incredibly good question and really hard to answer. So those two, let's take them together because they're both about the same sort of thing. Who wants to go first? I see Julie. Is she?
No, I'm very interested in the mention of emergent effects, and that kind of was where I was finishing off with in my talk. I had 3 more slides. The emergent effects is a big thing at the moment because we're not exactly understanding what those emergent effects are. I mean, we've been playing around with systems for some time to make them resilient to emergent effects, regardless of whether they're a result of security holes or a result of what happens in the environment. So, for example, Sadie mentioned earlier about routing. I mean, since the Internet of Things prior systems were invented, we've been doing dynamical routing to understand how we can keep the system up and running no matter what hits it effectively, whether it's regarding a security hole or whatever. And when you actually take these systems and analyse them against security hacks and so on, yeah, the effects that it produces on these kinds of systems is no different from the effects that the natural environment gives them. For example, you lose communication, you drain the battery, all those things. And when you abstract that away, then you can build the systems to be more resilient against those, regardless of whether it's a security hack or an environmental issue.
Okay, Sadie?
Yes, thank you. Excellent question. So just to pick it apart in a couple of ways, one of the areas in which we, as a community, have been working for some time has been looking at how we might understand forces of nature. We heard reference to it earlier, bio-inspired, but in this case, security mechanisms that might help us build in resilience to the system. So in a sense, how would you immunise a system and at what scale and how can it be done? And there has been some work that I've been involved with, but I know others are doing too, not just trying to design security mechanisms, but rather to come up with the scientific frameworks for analysing their effectiveness. So where people propose that they have some immunology against certain kinds of threat, how can we really have some confidence in that, and what kind of environments will it work in? To be more precise, do you immunise a city? Can you immunise somebody's home or the network on an individual's, or do you have to do whole regions? And taking very well understood mathematical models of things like disease spread amongst humans and all the different factors that impact that and replicating that for cyber. So certainly that is a route forward, and we need to do more when it comes to being able to replicate these results and also replicate the science that helps you reason about the effectiveness of these strategies for something as diverse as the IoT. So what I mean by that is the science so far does things like considers, for example, peer-to-peer computing, Bluetooth, that kind of thing, and how you might design an immunization strategy based upon characteristics of use, etc. So that's one cut at it. Another cut, bearing towards the emergent properties space is that of the formal methods community, where we have been looking at how you model systems in such a way that you can reason about their behaviour, and in particular that they will only behave in expected ways, and how we might reason about that. So they're very interesting pieces, and what that really goes to is the importance of having the science that enables us to reason about the performance of systems being developed alongside and in tandem with the actual bones of the technological and human bones of those systems, because it's one thing to create the stuff, we also need to have confidence in what we have created. And perhaps never more so than today, because one of the points I didn't get to on my slide is the convergence of machine learning at the same time as all of these other technologies, temporarily I mean, which means that we have this ability to analyse and understand patterns like never before, and that makes us and systems very predictable. It offers an opportunity for cybersecurity strategies in this space, but we might also want to reason about what might emerge in terms of knowledge and whether that's acceptable to us, for example, from a privacy standpoint, but we also don't want our security mechanisms influenced and gamed.
So Mac has...
So I'm actually going to try and address both of these. And Sadie's already mentioned this issue of the insider threat. And the use of, well, I'm going to quote Steve Ferber in this. He said, "We don't have AI, we simply have statistical correlation." So, deep learning that simply finds some statistical correlation in data and then says, right, this is truth and we will make predictions based on this, is very dangerous. And in fact, one of the piece of work I did with Rio Tinto is they had refused to deploy control algorithms where they were not able to understand what the statistics were in terms of mapping it back to underlying geology, physics, fluid mechanics, chemistry, to building a scientific model from which they learned better parameters, better control parameters, but they would not do it as a black box, which simply had found some statistical correlation, for fear that it might come across some situation which it had never seen before. And in fact, we will see this with autonomous vehicles and everything else. So it's really getting then to this issue of accountability. How do these things become accountable? And accountability is a very complex idea because it can sometimes mean accountability to the individual, it can mean accountability commercially or accountability to the law. In the case of Rio Tinto and the mining and the gas industry, they have taken this decision not to deploy these machine learning algorithms unless they can map it into some scientific model, because they fear they'll be in a health and safety court with a dead person and getting told, well, why did the system do what it did? And they said, well, we don't know. It was a statistical correlation. And that actually then, the question about what happens when you move one piece of technology to another and it doesn't seem to do the right thing, the chances are we didn't really understand how it worked in the first place. And formal methods have a place to play there. And in particular, I've seen some interesting work. It's in Muffy's program grant, looking at the issues of how can you formally model a system, at least to put a boundary around it, to understand when you've stepped outside what you know, so that we can actually make sure we don't apply these AI, you hit the term AI, these machine learning techniques inappropriately. And of course, Google has built lots of useful tools that people are out there throwing data at and saying, therefore we draw these conclusions. Most of them will be spurious because they've built tools that any fool can use. So we've got to be very careful with that. And I think it's going to come about, especially in the autonomous vehicles area, that we are going to demand much more accountability out of these systems because of the consequences they will have. And as I say, consequences where privacy has never won the argument, I'm afraid to say that mortality will.
What about this lady's...
That's what I was trying to say, was this issue of, we need... having these systems where we're not quite sure why they're working, as opposed to having accountability. So if this had learnt some behaviour, and then it gets moved to another place where that learnt behaviour was inappropriate. And it's actually quite a complex task. If I sell you a robot that's a learning robot, who gets to know what it learns? So if I'm General Electric and I sell Rolls-Royce a robot to work in their factory, now if you would ask that question of a human being, you would start talking about intellectual property rights, employment law, what's normal, what's a transferable skill versus what's something that's proprietary to the company. Robots are going to go through this every AI and learning thing is going to go through this, of who owns what it learns. Is it the manufacturer or not? So getting to that point, it's the issue of making these things accountable in some way to their behaviours, so that when we move them to a different situation, we know and we can say, well, that will not work because we need to get rid of that learned behaviour and go learn some new behaviour. Because the same thing, just moves from one place to the other, could have radically different behaviours.
Sitting here in the Royal Society, there were 2 reports recently, one on machine learning and the other one on data governance. I would urge you all to read them both, because they're both those reports address these areas, not specifically the Internet of Things, but of course it's in there, and there are recommendations to government which are being taken up in terms of data governance. But as we know, it's incredibly complicated. Bashir, anything you want to say about standards or regulation, or in your world? Does it not? No,
I mean, standards does not really apply to hardware.
What?
I mean, it's
Sorry.
I mean, the software people tend to...
Not in the same way.
Not in the same way. Let me start again. The way I view standards are very much that teamwork needs to come together, and to accelerate that, people need to understand how they interface. And it's all about interfacing. What the standard helps you is to make sure that what you get from somebody else will plug in with what you got. When it comes to hardware, that tends to be less common, because we tend to provide almost a black box with few things you need to connect to, and the rest is down to you. So from an engineering point of view, I think there has been huge progress made around how we could power up Internet of Things devices from ambient energy. I just hope, and I would encourage the other stakeholders to start to look at complexity from efficiency point of view, rather than adding more and thinking someone else will solve the problem for us, and that's where the policies and the standard might come in.
Okay, thank you. Now, right, there's 3 hands gone up here. There's one at the back. Let's go to the back. Let's go over. Camilla, go to the back first, and then we'll work our way up here. And Katie, just Katie. You go to the lady at the back there. Sorry, yeah, I couldn't see who was there. And then there's 2 hands. We'll take all these together, I think, and then we might come to you 2 last. Yes, do say who you are. I can.
My name is Wendy. I carry out research in Internet of Things security. I just want to make a suggestion that we shouldn't talk about accountability of things, because things cannot be accountable. We need to look at accountability of people, all the stakeholders in the Internet of Things, and responsibility as well. That's all. Thanks.
I might challenge the bit that machines can't be accountable. It depends how you interpret that. Right to the back this side.
Yeah.
So that was accountability.
Hi, I'm Supriya Rai. I'm from UCL. And my question is particularly to Professor Bashir. Have you ever thought of tapping energy from the epidermal potential, that is the potential of the skin, that is like tapping the energy of humans in order to power the devices? I think that could be one of the good areas to explore and also to invest in terms of research.
Okay, we'll take that. And there was the gentleman here in the middle, and then we'll go to this gentleman, and then we'll take that, and then we'll look at these 2 at the end.
Okay, thank you very much for fascinating talks, and I do also recommend the data governance paper by the Royal Society, and I'm very keen that that is taken forward. Sorry, I'm Gavin Jones. I'm an independent consultant, and I'm also with Smarter UK. So my question is, in order to get the real benefits of the Internet of Things for the world, do we really need a different approach to privacy and security, moving away from the focus on building walls to more of a focus on building resilience and stopping people doing bad things? I'm wondering whether the internet would have developed if we'd had the same thinking about building walls that we seem to currently have.
That's a very good question. Hugh pointed us to a company called Privitar, which is doing some interesting things in this respect. Yeah, go on.
Hi, Sasha Meckler from Analysis Mason. So a couple of quick things. 2 key points that both could be opportunities or threats in terms of this. The first being the economics aspect. So it's not just about the business models, but how are our economic systems going to fundamentally change? And I draw attention to Yuval Noah Harari's recent book. I don't know if any of you have read it, Homo Deus, which looks at central versus distributed data processing. And in the world of Internet of Things, are we really looking at the dominance of market-based economies, or are planned economies going to start becoming dominant again because we can actually make better decisions, and those are more efficient trajectories? And how does that affect all of this? And the other one is the environmental perspective. I'm very concerned about the proliferation of very low-cost devices that will then get thrown away after 1 year. Now, we're already unable to eat the fish in our oceans because of batteries, which get thrown away all the time. How do you see the environmental angle around actually having devices that are placed in the right place for a long period of time, that are seen as assets that maybe need to be recycled or returned like empty bottles are in Germany? At least because that also then will compel us to make clear choices about what we implement where, and the level of security we do. We'll be more thoughtful about it, as opposed to just implementing IoT in a consumption-based, and so the economy and environment then link back up there again.
Right,
Thank
we
you.
have 4 quite complex, and I'm really sorry. So I'm going to ask, Bashir, you were specifically asked about tapping energy from humans, which is, on so many levels, a very interesting question. And also the environmental perspective. Your talk was batteries not included. So.
Sure. The simple answer, yes, there are some research groups in the world that are looking into that particularly. I personally have not looked into this myself. So that's the answer to that one.
But it's a good research challenge.
Oh, absolutely.
For wearables.
Absolutely. In terms of the environment, I fully agree with you. I think what we need to do is to work out what is it we want to do and how we do it efficiently, rather than think, let's generate as much data as possible and try to see how we could do something useful with it.
Right, we have questions on accountability, different approaches to privacy and security, environmental.
You do environmental. Just to follow up on Bashir, there's a sort of movement at the moment in this field where, like traditional computing, where we had these unique machines, and then we started to build ways of maintaining them over long distances of time. To be honest, in our field, we've been a bit slow on that one, but there are now mechanisms whereby we keep the systems running longer. So the systems that go out, we're looking at tens of years rather than a couple of small, quick proofs of concept, which is what we've been doing, to be honest, for the last few years, except for wired sensing systems. So we're starting to look at that. We're starting to look at long-term maintenance generally, so that's software updates and that side of it. So we're starting to mature the technologies in that respect, therefore lengthening their lifetimes. And then there are people looking at biodegradable units and things like that, and obviously recycling as well. So there are people starting to look at towards longer-term systems.
Sadie, what do you like pick up on?
So much to pick on, but I'll start with the energy from humans piece at the back. The research I'm aware of, I think there's been good progress made on harvesting energy from natural movement of the human body. It's a little bit like wave energy, isn't it? Yes, yeah, quite so. My understanding is, in terms of fueling the devices that the person might be carrying, I'm not sure whether we've reached the point where you're going to be selling it back into the grid, but no doubt it's going to be. We'll be arriving at it. We'll be tapping in, won't we?
That could be a challenge for some people, couldn't it? A competition.
And to pick up on a few of the other points, in particular, I think there's a convergence of 2 questions on the environmental side, because earlier on somebody asked us what we could have learned from space science, and you can imagine it costs an awful lot to get a satellite up in space. A lot of engineering, a lot of equipment, and they're very hard to get up to and change. Well, not necessarily hard, but expensive. And so we have for some time learnt about how we can re-provision technology to deliver other functionality and the importance of planning. So that's one angle, and combine that with things like field programmable gate arrays, work that's come out of computer science and hardware and software together, so that we can change the functionality of chips once they've been deployed in the field. That's been around a while. No doubt that's going to offer opportunity to try and avoid some of the environmental hazards. But nonetheless, there's also work on how can we make these things so cheap that they are disposable almost. And we can afford to just leave them in the environment. So I think you're quite right to raise it, and I suspect there's some way to go in order to address it. But I think I ought to pick up on the moving towards resilience point that was being made earlier, and I would agree absolutely we must. I mean, we cannot, have we not seen, all of us in the press in the last few years, examples of what can happen when somebody inside a system decides they want to act against it and give all of the secrets away, for example. Well, that could play out in a number of ways and create a number of harms in the future, and so we must not assume that we can rely on perimeters. In fact, we've been saying that for some years. Therefore, yeah, absolutely, we will have to work towards a resilience mechanism. My suspicion is that there'll be a massive opportunity in IoT. Almost cybersecurity as a social machine. I imagine we'll be moving towards much more collaborative models, and the name of the game will be to produce the analytics to really understand what the emergent security properties being delivered are, and how we can incentivize the system, whether it's economically or in some other means, to behave in a more resilient manner, and recognizing that humans, organizations and tech is inside the system. And I will shut up in a moment. That brings me on to the accountability observation, which is very interesting, because you might be quite right. I don't know, I'm not a lawyer. The way in which the law is currently set up might well say that a human being or a legal entity has to be accountable for things. And those are the things that also get to take out insurance policies to try and transfer the risk. And we are seeing, of course we are, a fast-paced evolution of the cyber insurance market. But nonetheless, I don't think we can ignore the machine learning. Is it the fourth wave? You were fourth?
Yeah,
I think you said the fourth wave.
Yeah.
We would be very naive if we were to imagine that we aren't going to very quickly arrive at an environment where there are automaton that are doing stuff that looks a lot like stuff that human beings and organisations can do. And so I think it would be foolish of us to imagine that the current governance structures, the way in which we organise our societies, are going to be fit for purpose in the next 50 years. My suspicion is that IoT and everything that it promises is also going to be challenging that, and that we'll be revisiting what is accountable for what and under what conditions, and that will be incredibly important when it comes to things like managing our risk. Because at the end of the day, if you look at the most recent cybersecurity attacks that have happened in the last couple of years, they're still playing out in the courts in terms of who's liable. It's hard to imagine that we will be able to maintain a situation where we don't at least reflect upon and investigate the responsibility of automaton in some of these environments.
Absolutely. We'll be discussing this a bit later on. Mac, briefly? And then...
Yeah, I mean, I think the first thing is that, unfortunately, I've been hanging out with social scientists for too long. And in fact, I got my reading the other day, go read Durish's paper on techno-methodology, 60 pages of it, in which accountability is used in very different ways. So there certainly are elements of making companies accountable for the technology they deploy, and that's exactly where those responsibilities lie. In legal accountability is one thing. But actually, when humans and technology interact, we also use the accountability to mean how do they understand each other? I don't think Nick's here today, but certainly Nick Jennings at Southampton and
Imperial.
He's now at Imperial. He was at Southampton when he had his program grant on human computing agents and how they would interact. If you can replace a human agent with some piece of technology in a complex network, and they were looking at things like disaster management, then the behavior of these systems needed to be accountable in the sense that they could say why they did something. And this is actually about so that the humans and the systems can actually reason with each other and try towards some other goal. And that's a very different use of the term accountability, and that's about explication rather than explanation, about understanding by your interactions with something what it's going to do. And it's actually that sort of everyday interactions with things that builds trust. And so as we build these much more complex systems, I use the word accountability, and the accountabilities are very diverse and complex. Some of them are legal, but some of them are about how humans and systems will interact in the future and understand each other's behaviors. That is simply the interactions they engage in. So in that sense, you're using it in a very, well, we could use the word social machines, but in a very social context of how this all comes from social sciences about how people interact, And if we imagine that we can replace some of those agents, some of those people as with technology, then we'll want to be able to say to the car, why on earth did you just do that? And if it just says, because there was a statistical correlation of 92%, we go, what? No, what? Why did you do that? We need explanations.
Okay, panel, think about your last sum-up comments. I did promise these two gentlemen the last word. You've got to be brief, though, because we're running into coffee here. So there's two gentlemen at the front there. Each had a question, I think. If you could be brief.
Okay, I'll be brief. Chris Cole, Liverpool Centre for Forensic Science at the University of Dundee. So forensics touches on accountability and security and all the things that we talked about recently. So what is IoT an opportunity or a threat in terms of scene of crime, investigation, and evidence types and data, at that level?
I think that's a good comment. We may not be able to answer that at time. We'll see if anyone's got a quick answer to that. And
a comment and a question. Thank you very much for Wendy. You touched on it, but a diverse panel we got up there. I had to text my partner. But I'm Roy Moody from the Leverhulme Research Centre of Forensic Science, along with Chris. And my question is about the physical and the environment things that you're touching on, and the accountability of that data that we're collecting. And again, from a forensic end, how can we? Are there any research outcomes that are commenting on how accurate or how well, exactly that, how accurate those information that we're collecting is?
Okay, very good comments, guys, from the forensic world. Panel, we're into coffee. You've got like a nanosecond each. No, that's not fair.
Okay, I think both questions are answered from the same thing. Basically, it depends on what's been implemented in sensing in that environment at that time. And if whether or not, for example, if somebody were to jam that system at that moment in time, how you could derive the data from the data that you had before and after the event happening. So you'd have to have an understanding of the quality, back to quality of data that's coming off those systems, and an understanding of maybe the history of those systems in operation under normal circumstances to be able to derive maybe errors and bounds and so on from that. And that's the way I would approach that particular thing.
Yeah, but Sadie.
Yes. Both. It's both an opportunity and a threat. I have a doctorate student who's just finishing up, who's not a forensic scientist. He's a cop, not from this country. And he has been looking at semantic web technologies and all of the variety of data that you can collect, and sharing that and deriving interesting ontologies that would speed up the process of generating intelligence from the data. So that's an example of an opportunity, and I'm sure there's many more. And of course it's a threat because this stuff's vulnerable to attacks against its integrity. So as you become dependent upon this IoT-enabled data source to enrich your understanding of a scene of crime and what's been happening there, so you'll need to be eyes wide open to the fact that somebody might have been in there and changed what you're seeing. And even today, just basic stuff like the ability of people with high degrees of confidence to influence what you think you're seeing on a video of somebody, a camera in the room, it is them, their ability to create an image that looks like them and moves like them but was never really there. Well, that's here and now. And so as we move into IoT, of course, the possibilities are endless in terms of manipulating that crime scene, but the possibilities are endless in terms of what additional intelligence you might gather. So it's yes.
All of the above. Last word, Bashir.
As designers of Internet of Things, as users of Internet of Things, please think of energy usage. Energy matters.
Mac, last word from you.
So, I presented with the idea about, instead of gathering all the data all the time, actually doing the analytics at the edge and reducing the data down to the minimum required. That actually would then lead to the fact that all that data is recorded means that it's a treasure trove for forensics. But on the other hand, for power reasons, one of the reasons you want to compute all the data at the edge and then transmit the minimum amount is for a lot of these systems, the communications bandwidth is the bottleneck. What's for the smart meters, for example. So essentially, it will be a treasure trove, but I would actually say for privacy reasons and other reasons and power reasons and resilience, we'll actually be wanting to do much more processing of data at the edge, which will mean it will not be available for other uses and other interpretations. If we actually get it down to the minimum data required and the information content required to address some global optimization, the chances are a lot of your forensic data is gone.
Absolutely agree with that.
You don't know.
No, I totally agree with that because that's how my water network works. 10K samples a second. I'm compressing it all down to one message.
Okay.
All your forensics are gone. But
We've got,
I've got
to finish. Yes, you have. Sorry, we're already nearly 10 minutes late for coffee. So, great panel. Thank you. Got everybody going now. So, there were so many questions asked. We could have dealt with more. The security panel will pick a lot of this up, I expect. So, 20 minutes for coffee. Can you be back here by, is that right? 20 past 11? And thank you very much, panel. That was brilliant.